So today I'm going to try to explain a little bit about sound hearing waves by Catalina Arias. It's a form of energy that can dissipate over time. Sound waves are being transmitted through gases, plasma, solids, and liquid as longitudinal waves, also known as compression waves, and these are vibrations traveling through a medium. Now, how do we hear? And this depends on steps that changes sound waves through the air into electrical signals. Now, how the ear works. So the eardrum vibrates from incoming sound waves that sends vibration to three little bones, the middle ear, the ossicles, and the inner ear. So first it enters the outer ear, where then it passes the middle ear, where you can find the ossicles, and finalize in the inner ear, that it's called cochlear. And then there are sound vibrations activity, tiny hair cells in the inner ear, which releases neurochemical messages. And these auditory nerves get carried to the electrical brain, which translates into sound that we are able to understand. Now, what are sound waves called? These are longitudinal and transverse waves. So longitudinal waves is when an air vibrates along the same directions the wave travels. And transverse waves is when there's a vibration at 90 degrees to the wave. So which one can be transmitted faster? In this case are the solids that has the faster capacity to be transmitted. And these can be transmitted through longitudinal waves and transverse waves. Then of solid goes liquid and finalize in gas. What is refraction of sound, and why do sound waves speed up when they go from air that is a gas to water that is a liquid or glass that is a solid? And this is because sound waves are caused by the vibration of particles, and the vibration of the particles in a substance cause sound waves to be produced. So how speed changes in sound? So the denser the material, the faster the sound travels. And you can notice this with the example comparing copper with hydrogen. How sound is carried, and this is an alternation in air pressure that is carried through compressions and refractions. So compression is when all the particles are closest together, and refractions are when they are furthest away. In compressions, the energy goes through the body of air, and refractions, they change in direction of waves as they pass from the medium to another. For example, we can notice this is with an echo, that is when the sound bounces off an object and then it returns. So the higher the frequency, the shorter distance between each compression. You can notice there is a compression and in the other is the How do humans react? So all sounds are made by vibration of molecules, which help notice different types of sound. So sound waves have a distinct pitches when frequency lies between 20 to 20,000. It is dangerous to hear higher frequency because we can lose the ability to hear. So in this example, we want to find out the speed of a frequency of 256 of the sound with a wavelength of 1.35. So basically, you need to multiply your frequency with your wavelength to find the velocity. So the final answer will be 346 meters per second. We will do an activity to see how our ears react to three different sounds, and we're going to do how the wavelength will look like. We're going to see how sound waves changes throughout the day. So we're going to test in the morning, in the afternoon, and in the evening. Now it's 7:07.
I can't hear a word you say. I'm talking loud.
2:38. And let's see if the sound has changed.
I can't hear a word you say. I'm talking loud.
6:11. And let's see if it changed.
I can't hear a word you say.
So based on these labs, sound waves can gradually change air temperature, which means that they're gradually changing the wave speed. For example, during the day, the air is warmest, right next to the ground, and grow cooler above the ground rather than in the night. So we're going to do a quick summary. So we need to understand that sound is a type of energy that sound waves are being transmitted through gases, plasma, solids, and liquid, and they're transmitted through the longitudinal waves. We also need to understand that longitudinal, it's when it vibrates at the same directions, and transverse waves, it's when it vibrates at the 90 degree. Then we need to understand how the ear works, that you can go and see again the video that I explained step by step. And then finally, we need to understand that compression, it's when all particles are closest together, and refractions, it's when they're farthest away. Hope you liked this video, and if you did, please like it. Thank you.